Space, the final frontier. It beckons us with a sense of wonder, a desire to explore the unknown. But as we set our sights on the cosmos, we must also confront a crucial question. How can we explore space sustainably? Imagine lunar bases powered by the sun. Picture spacecraft designed to leave no trace, orbiting Earth without adding to the debris field. This isn't science fiction, it's the future we need to create. Sustainable space exploration is about more than just reducing our impact. It's about ensuring that space travel remains viable for generations to come. It's about preserving the beauty and wonder of space for our children and grandchildren. Our future among the stars is linked to the health of our own planet. For centuries, we've looked to the stars with a sense of awe and inspiration. Today, space exploration is no longer a distant dream, but a tangible reality. Environmental scientist as S2. Yet, with every bold step into the cosmos, we must acknowledge the responsibility that comes with it. Space, while seemingly vast and inexhaustible, is not immune to our actions. Space debris, remnants of past missions, pose a growing threat to spacecraft and future exploration. The environmental impact of space travel, from rocket launches to the potential contamination of other planets, cannot be ignored. Our ventures beyond Earth must be guided by a deep respect for the delicate balance of these celestial environments. We have a collective responsibility to ensure that our pursuit of knowledge and adventure doesn't come at the cost of the cosmos itself. The challenges of sustainable space travel are significant, but so are the opportunities. As we grapple with the complexities of venturing beyond Earth, we're uncovering innovative solutions that could revolutionize not just space travel, but also life on our own planet. Space engineer, as S1, scientists and engineers are pioneering technologies that hold immense promise for a sustainable future in space. Reusable rockets capable of launching payloads into orbit and returning to Earth for refurbishment are already reducing the cost and environmental impact of spaceflight. Closed-loop life support systems, inspired by Earth's own ecosystems, aim to recycle air, water, and waste, minimizing the need to resupply missions from our planet. These advancements are not limited to the realm of space exploration. The technologies we develop to make space travel more sustainable can also be applied to address pressing challenges on Earth. Water purification systems designed for space stations could provide clean drinking water to remote communities. Space exploration is fueled by a thirst for discovery, a desire to push the boundaries of human understanding. But this pursuit of knowledge comes with a cost, one that weighs heavily on the resources we extract from celestial bodies. Space engineer, as S1, water ice on the moon, rare earth elements on asteroids. These resources hold immense value for future space missions. Yet, if we're not careful, our extraction efforts could mirror the unsustainable practices that have plagued our own planet. Imagine a future where lunar water ice, crucial for life support and fuel production, becomes depleted due to unchecked mining. We must develop sustainable extraction techniques that minimize environmental impact and ensure the long-term viability of celestial resources.
A cosmic junkyard. The growing threat of space debris. Every rocket launch, every satellite deployment leaves behind more than just footprints in the cosmos.
Defunct satellites, spent rocket stages, even fragments of paint, these remnants of past missions, orbiting Earth at high speeds, pose a significant and growing threat to active spacecraft and future exploration endeavors.
Imagine a tiny fleck of paint traveling at thousands of miles per hour, colliding with a satellite or a manned spacecraft. The impact, even from such a small object, can be catastrophic.
This debris field, this cosmic junkyard, is not just a theoretical problem. It's a clear and present danger that could hinder our access to space. Addressing the space debris problem is not just about cleaning up after ourselves, it's about safeguarding our future in space.
Footprints on the moon echoes in the cosmos, environmental impacts, the allure of pristine lunar landscapes, the untouched beauty of distant planets. These images fuel our desire to explore.
The environmental impacts of space travel, from rocket launches to the potential for contamination, cannot be ignored.
Consider the fiery ascent of a rocket, its exhaust plumes releasing pollutants into the atmosphere. Picture robotic rovers traversing alien terrains, potentially carrying with them microbial life from Earth. Our exploration should be guided by a reverence for the pristine beauty and scientific value of these celestial environments.
Pioneering a sustainable path, reusable rockets take flight. For decades, the image of a rocket soaring into space was forever tied to the image of its fiery demise.
But what if these powerful machines, capable of carrying us beyond the bounds of gravity, could be flown again and again?
Enter the era of reusable rockets, a game changer in the quest for sustainable space travel. Leading the charge in this revolution is SpaceX, with its Falcon 9 and Falcon Heavy rockets. These marvels of engineering are designed to not just deliver payloads into orbit, but to return to Earth, landing upright with precision and grace.
Imagine, no more single-use rockets left to drift as space debris. Instead, these reusable spacecraft are transforming space exploration into a more sustainable endeavor. Reusing rockets significantly reduces the cost of space travel. This affordability opens up space exploration to more players, fostering innovation and competition. A closed loop in the cosmos life support systems inspired by Earth. Imagine a spacecraft as a miniature Earth, a self-sustaining ecosystem hurtling through the void.
This is the vision behind closed-loop life support systems, a cornerstone of sustainable space travel.
Instead of relying solely on supplies from Earth, a costly and unsustainable approach for long-duration missions, closed-loop systems recycle and regenerate these vital resources. Water is purified and reused. Air is cleansed and replenished with oxygen.
Waste products are transformed into fertilizer for growing food, mimicking the natural cycles that sustain life on our planet. These systems, still under development, hold immense promise for long-duration missions to the Moon, Mars, and beyond.
From waste to resource recycling in the final frontier. On Earth, we're increasingly aware of the importance of recycling, of transforming waste into valuable resources.
This same principle takes on even greater significance in the context of space travel. In the confines of a spacecraft or a lunar outpost, every ounce of material matters.
Imagine a 3D printer humming away inside a spacecraft, transforming plastic waste into tools or spare parts. Picture astronauts using composting techniques to break down organic waste, creating nutrient-rich soil for growing food. Recycling reduces the need to launch new materials from Earth, saving precious resources and reducing the environmental impact of space travel. Beyond the horizon, extending human presence with sustainable practices. For centuries, our exploration of space has been limited by the resources we could carry with us.
Sustainable practices hold the key to breaking free from these constraints, enabling us to extend our presence in space far beyond what was previously imaginable. Imagine lunar outposts, powered by the sun and supplied with water ice extracted from the lunar surface.
Picture astronauts on Mars, cultivating crops in Martian soil, their habitats recycling air and water in a closed-loop system. These scenarios are no longer the stuff of science fiction. They are the attainable future made possible by sustainable technologies.
A legacy among the stars, minimizing our footprint for future generations. As we venture further into the cosmos, we carry with us a profound responsibility.
Imagine a future where the orbits around Earth are clogged with debris, remnants of our short-sightedness. Picture the surfaces of other worlds, scarred by unchecked resource extraction, their potential for life compromised. This is not the future we strive for.
By embracing sustainable practices, we can ensure that space exploration remains a viable and awe-inspiring endeavor for centuries to come. Let us explore, but let us do so with care, leaving only footprints of knowledge, not scars of indifference.
The economics of sustainability, long-term vision, long-term savings. In the realm of space exploration, sustainability is often viewed through the lens of environmental responsibility.
Consider the paradigm shift brought about by reusable rockets. The ability to launch, land, and relaunch these vehicles drastically reduces the cost per mission. No longer are we discarding millions of dollars worth of hardware after a single use.
This economic advantage extends beyond launch vehicles. Recycling initiatives within spacecraft and lunar or Martian outposts reduce the amount of material that needs to be transported from our planet, further optimizing mission costs.
A shared cosmos, the imperative of international collaboration. Space in its vastness transcends the boundaries we've drawn on Earth. It belongs to no single nation, no single ideology.
Imagine a future where spacefaring nations operate in isolation, each pursuing their own agendas without regard for the collective impact. Space debris could proliferate unchecked. The potential for conflict over celestial resources could escalate.
Sustainable space exploration demands a united front. By embracing a spirit of cooperation, we can ensure that space exploration benefits all of humanity, not just a select few. Beyond borders, towards a sustainable future, agreements and partnerships. The foundation for international collaboration in space was laid with the Outer Space Treaty in 1967. This agreement established space as a global commons, free for exploration by all nations.
It prohibited weapons of mass destruction in orbit, emphasizing peaceful space exploration. Numerous international agreements and partnerships address space sustainability.
The IADC developed strategies for mitigating space debris. The International Space Station symbolizes the power of international collaboration.
These agreements are just the first steps on a long journey. As space exploration evolves, so must our mechanisms for collaboration.
We need stronger agreements, bolder partnerships, and a shared commitment to peace and sustainable progress in space.
Section 3. United by a common goal. Harnessing global expertise and resources. The challenges of sustainable space exploration are multifaceted and complex. They require expertise from a wide range of disciplines, from aerospace engineering to environmental science, from international law to resource management.
No single nation possesses all the answers. It is only by pooling our collective knowledge and resources that we can hope to overcome these challenges and unlock the full potential of space exploration.
Imagine scientists from around the world working together to develop innovative technologies for closed-loop life support systems. Picture engineers from different space agencies collaborating on the design of spacecraft that minimize environmental impact. Envision policymakers from different nations crafting international agreements that ensure the responsible use of celestial resources.
This spirit of collaboration, this willingness to share knowledge and learn from one another, is essential for driving innovation and accelerating progress towards a sustainable future in space. By harnessing the global brain trust, by leveraging the diverse perspectives and expertise of the international community, we can overcome the technological, environmental, and political hurdles that lie ahead.
Section 1. A future written in the stars. Sustainable space exploration within reach. As we stand on the precipice of a new era of space exploration, we are presented with a choice. We can cling to the unsustainable practices of the past, jeopardizing the very environment we seek to explore. Or we can choose a different path, a path that embraces sustainability as the guiding principle for our ventures beyond Earth.
The challenges are undeniable. Resource depletion, space debris, the environmental impact of space travel. These are formidable obstacles that demand innovative solutions. Yet, amidst these challenges lies a profound opportunity. An opportunity to redefine our relationship with space, to ensure that our pursuit of knowledge and adventure doesn't come at the cost of the cosmos itself.
The seeds of the sustainable future have already been sown. Reusable rockets are transforming space travel, making it more affordable and less wasteful. Closed-loop life support systems, inspired by Earth's own ecosystems, promise to minimize our impact on celestial environments. International collaborations are fostering a spirit of cooperation, uniting nations in the pursuit of a common goal. Guardians of the galaxy, our shared responsibility to the cosmos. For generations we have looked to the stars, dreaming of venturing beyond Earth. That day is upon us. We are not conquerors, but caretakers.
The cosmos is not ours to exploit. It is a fragile ecosystem, interconnected in ways we are only beginning to comprehend. Our actions can ripple through the solar system, shaping destinies.
This is a responsibility we cannot shirk. We must minimize our footprint and enhance the cosmos. Respect celestial environments for future generations.
Section 3. To Infinity and Beyond Sustainably. A vision for generations to come. Imagine a future where space travel is commonplace. Lunar cities gleam under Earthlight and human outposts dot Mars. Spacecraft gliding silently, powered by the sun, leaving no trace. This is a tangible future within our grasp.
Achieving this vision requires a paradigm shift in space exploration, commitment to sustainability in every aspect, international collaboration, transcending political differences.
The rewards are immeasurable, ensuring space exploration remains viable for generations, creating a legacy of responsible stewardship for our children and grandchildren.